ครับที่มาจากประเทศเกาหลีใต้แล้วเนี่ยยังสื่อถึงเป้าหมายและวิธีการออกแบบผลิตภัณฑ์ของเขาด้วยที่เน้นการรักษาที่สามารถทำเสร็จได้ภายใน1 วันหรือภายในวันเดย์นั่นเองนะครับก็คุณหมอหลายๆท่านก็น่าจะทราบว่าการทำการรักษารากเทียมให้คนไข้ได้ใส่ฟันภายใน1 วันนั้นโดยเฉพาะในเคสฟูเมาส์มันไม่ใช่เรื่องง่ายเลยนะครับก็หมายความว่าผลิตภัณฑ์ตัวนี้มันจะต้องมีคุณภาพที่สูงมากเพื่อให้ได้ทำตามแผนการรักษาที่คุณหมอวางไว้นะครับก็ปีนี้ก็จะเป็นปีแรกที่ทาง OneDay Biotech และบริษัท DDSL จัดงานประชุมวิชาการนะครับเพื่อยกระดับทักษะการทำรากฟันเทียมรวมถึงแชร์ประสบการณ์จากสปีกเกอร์ผู้ทรงคุณวุฒิแถวหน้าในแวดวงทันตกรรมระดับนานาชาตินะครับรวมถึงด้านหน้าก็จะมีบูธสินค้าหรืออุปกรณ์ด้านทันตกรรมจัดโชว์อยู่นะครับก็ไม่ว่าจะเป็นพวกรากฟันเทียมพวกเครื่อง Intraoral Scanner พวก 3D Printer นะครับเดี๋ยวผมขอพูดภาษาอังกฤษนิดนึงนะครับ So good morning to all doctors joining us at the Secrets of OneDay Implant seminar. My name is Dr. Krasawan Kongkapit and I will be your MC for today. So many of you may be wondering why this implant brand is called OneDay. OneDay Biotech is not only the name of a dental implant brand from South Korea, but it also reflects the company's goal and product design philosophy, focusing on treatments that can be completed within 1 day. As many of you may know, providing implant treatment that allows patients to receive their teeth within a single day, especially in full mouth cases, is by no means easy. This means that the products used must be exceptionally high quality in order to achieve the treatment plan outcomes. This year marks the first time that OneDay Biotech and DDSL have organized an academic conference aimed at enhancing dentistry skills, as well as sharing clinical experience from leading internationally recognized speakers in the dental field. There are also exhibition booths featuring dental products and equipment located outside the conference hall for you to explore. Today's seminar is scheduled to run from approximately 9 to around 6 p.m.
병원을 소개를 시켜야죠. 그래서 우리 원데이 병원.
อันนี้ก็จะเป็นตารางเวลานะครับ This is the schedule for today.
앞에 조금 얘기하고 있죠.
우리 왜 우리가 써야 되는지 전 요즘 그거에 대해서 생각을
그걸 하고 있죠.
So, for our first topic today, how to perform implant placement easily and efficiently using OneDay Biotech systems. We are honored to welcome our distinguished speaker, Dr. Kim JinHwan. Dr. Kim currently serves as president of the Korean Academy of Aesthetic Dentistry, vice president of the Korean Academy of Stomatognatic Function and Occlusion, director of the Korean Academy of Digital Dentistry, and most importantly, CEO of OneDay Biotech, as well as OneDay Dental Clinic,
Yep.
The #1 implant clinic in the Gangnam area of Seoul. I speak in Thai.
Yeah, okay, good. Just
ครับก็สำหรับในหัวข้อแรกในวันนี้นะครับก็จะเป็นเกี่ยวกับเทคนิคการฝังรากเทียมอย่างง่ายและมีประสิทธิภาพด้วยระบบ OneDay Biotech นะครับโดยเราได้รับเกียรติจากวิทยากรผู้เชี่ยวชาญทันตแพทย์ดร. คิมจินวานนะครับซึ่งปัจจุบันอาจารย์คิมเนี่ยเป็นประธานของ Korean Academy of Aesthetic Dentistry เป็นรองประธาน Korean Academy of Stomatognatic Function and Occlusion นะครับเป็นผู้อำนวยการ Korean Academy of Digital Dentistry และที่สำคัญนะครับก็จะเป็น CEO ของบริษัท OneDay Biotech รวมถึงเป็นเจ้าของคลินิกทันตกรรม OneDay ซึ่งจะเป็นคลินิกรากเทียมอันดับ 1ในย่านกังนำของเมืองโซลที่ประเทศเกาหลีใต้ด้วยครับก็ขอเรียนเชิญครับ please
okay. Thank you.
ขอเสียงปรบมือต้อนรับเลยครับ
Thank you. Thank you. Thank you. Hello, everybody. Yeah. Just a minute. Okay. Okay, good. Okay. Hello, everybody. I'm JinHwan Kim, and Dr. Kim just called me the Chin. Yeah, so I'm so happy to be here. These days in Korea is a very freezing cold. It's just a minus 15 degrees Celsius. Just 6 hours of flight to the Thailand. So from the winter to summer, I love the summer. But it is hot, warm, but I like to be here. I'm happy to be here. And then very thank you for coming and joining us here. Yeah. So I'm happy to present in front of you. So first, I briefly introduce myself and my company. Then I will show you my products and techniques for performing a surgery more easily and quickly. I'm in the JinHwan Kim, and I'm a CEO of OneDay Biotech and OneDay Dental Clinics. I'm running OneDay Dental Clinics for 25 years, and I also running one lab, the laboratories in Gangnam area. So you know that Gangnam area is a Gangnam style, so it's a very competitive place in Korea. So I have 27 years of experience as a dentist. I graduated at Seoul National University in top #1 schools in Korea, the dental school. I got a PhD on SNU, it's the Seoul National University, with a particular interest in dental occlusion and implant. So I've been actively researching and teaching about a T-scan. You know that a T-scan? How many people, the guys that you know T-scan? These are occlusion device in checking a device occlusions. I think that occlusion is the most key things to deliver the prosthetics in the patients. So I've been researching and teaching and writing about T-scan. These are occlusion analysis device. Currently, I'm a previous president of a Korean Academy of Aesthetic Dentistry and director of a Korean Academy of Digital Dentistry and vice president of the Korean Academy of Stomatognetic and Functions Occlusions. This is a T-scan. So I dedicated to about 20 years of digital occlusion analysis device. It was developed in 1984 since Robert Costin. He is my mentor and teacher. He developed. He has been developing and researching and teaching. He authored the edited T-scan textbook published in 2014, 2018, 2024. I contributed the chapter on the implant occlusion in all these 3 books, which is published in IGI Global in USA. If you look at a lot more details and knowledge, you can buy it in an IGI Global online website in USA. So I have an interest in digital occlusions from early on. In 2009, I started developing an intraoral scanner. That time there is no open system intraoral scanner. This is my intraoral scanner. I scan it at once, just 4 or 5 teeth immediately and scan the same coordinate. That time there was no open system intraoral scanner, but these are all a lot of intraoral scanner, even though the Shining 3D, the Chinese one is very good, and the Korean ones, I Medit, but I started a company, Medit started developing intraoral scanner maybe in 2014 or something, but I started in 2009. But I wanted to develop open system intraoral scanners, but unfortunately I failed. This failed. Back then, intraoral scanner was not widely used. Only a few people were familiar with the concept of scanning teeth. This is one using a source, light beam source, laser line sensor. But back then, all the scanners are using a white LED. But the line laser is very expensive, so it is hard to learning on developing my intraoral scanners. So I failed. I spent a lot of money to make a lot of loan. So anyway, these days I'm running an implant company, OneDay Biotech, named my clinic name, OneDay Dental Clinics. One day is not the same as some days, but a single day. I want to complete all the procedures in a single day. This is my philosophy that I pursue. That's the reason why I developed intraoral scanner. Intraoral scanner is essential, so inevitably required to make it all the procedures on a single day. So I failed though, but I've been doing my best to reflect that lifetime passion, long time passion in my implant company and in its products. OneDay Biotech pursued to contribute to human health by popularization of the implant in the worldwide. And OneDay Biotech pursued consumers' value by ensuring an easy and fast, as well as a quick and effective of healing. Satisfied both patients and the dentists, we develop high quality, functional, and product and continuously improve our manufacturing standards. Our goal is to help people worldwide benefit from advantage dental care by innovating and distribute and manufacturing process. Through our customer-oriented approach, we support our customers and success while growing and evolving alongside them. The company was originally established in 2016 by Jimmy Song. He's Jimmy Song, under the name of OneDay Biotech. In 2020, I acquired OneDay Biotech and rather rebrand the company as OneDay Biotech in line with the philosophy of OneDay Dental Clinic, my dental clinic name. We obtained FDA approved in 2020 and CD certification in 2021. With over 25 years of clinical experience in implant dentistry, I've personally used the OneDay Biotech implant for past 6 or 7 years. Throughout this period, I've incorporated my clinical know-how and insight directly into my product development and continuously refining and improving the implant system. As a result, these efforts, we received an NMPA approval in China in 2024 and obtained a regulatory certification in Mexico last year. Let's get to the point. Firstly, I show you my unique drilling system for osteotomy, and it's called the OneDay system. It helps dentists to perform a surgery in an easy and fast way. One drill minimizes surgical time and ensure precise directions, and allow for autogenous bone collection. In this article, surgical time is highlighted as a critical factor in complications. This article explores about the relationship between the surgery time and the complications. It shows that if surgery time lasts 2 hours, the risk of complications is double. Additionally, increase the 30 minutes of additional operating time and surgery time increase likelihood of complication by 14 hours. This is a OneDay system. This is how it looks. Final drill. We are providing a full size of a drill according to the diameter of implant size. 3.8, 4.0, 4.5, and then 5. This is for 5.0 diameter fixture. To place the implant, OneDay system needs only 2 steps. Compared to conventional way, it is easy and fast. If you place a 5.0 diameter implant, you need at least 3 or 4 or more osteotomy steps in conventional way. But OneDay needs only 2 steps. Guide drill for perforating cortical bone. After that, they're using a final drill. This is a guide drill which has a sharp edge and guided part of a final drill. This is a final drill. This is a 4.0 diameter fixture. Laser marking indicated every 1.5 millimeter from 7 millimeter long to 13 millimeter long. It looks like a trap-in bar. Has a hollow structure. It has a hollow structure made of trim light with black coating. Laser marking is indicated every 1.5 millimeter, as I mentioned. Technically, one drill covers a 13 millimeter length picture, but it can create an osteotomy 15 millimeter, just a wide dimension of 0.0 millimeter and adding just a 1.6 safety margin at the top. You can create a 15 millimeter length osteotomy. We published the OneDay protocol in this journal, so if you want to know the more details, you can look it up on the internet. These articles that you can search in some kind of OneDay systems protocol. And many studies are comparing trap-in bars and conventional drills, a twist drill, in terms of hit generations. Result has been inconsistent. Some studies reported that trap-in bars generate more hits, while other reports no significant difference or even lower hits generate compared to the twist drill. From the structural perspective, trap-in bar forms a 360 degrees circumferential lane. That means that during the osteotomy, continuous circumferential lane contact to the bone contact to the bone. That generates the hit more and more. But another studies not agreed with that. So apply the actual pressure. It may increase the frictions, which can potentially lead to greater hit generations. Anyway, however, unlike a conventional trap-in bar, the OneDay has a hollow structure. But without a fully closed 360 degrees ring, it's not a 360 degrees ring. It features an open slot and helical cutting edge. This is a cutting edge. The creating an open hollow proves architectures that differs fundamentally from trap-in bar. This is our test on the bone hitting. Because the OneDay has a hollow structure, it generated only half hits compared to the conventional drill during the osteotomy. As you can see, with the conventional drill, materials can heat up to over 60 degrees Celsius. However, this doesn't mean the same temperature is applied directly to the bone. As you know, if the temperature over the 47 degrees for more than 1 minute, it can cause the bone damage, reducing regenerations. This is a background of bone healing articles. Animal study, very classic. Critical temperature and threshold, about a critical temperature and threshold. 47 Celsius degrees and 1 minute is a critical threshold. Was identified as a critical threshold at or above the level. Reversible bone damage occurred. Osteonecrosis was observed and bone remodeling capacity was significantly reduced. When bone was exposed to over 47 Celsius degrees, microvascular stasis occurred. Blood flow was permanently impaired. Osteocytes showed degenerations. New bone formations was delayed or absent. The author emphasized that hit generations during the drilling must be minimized. As you know, that surgical protocol should be ensure adequate irrigation, copious irrigations, and the sharp cutting edge and instrument and controlling the drilling press and speed. That is the key. So this is the advantage of the OneDay system. Minimize the surgical time and ensure the precise directions and allow for autogenous bone collection. And we decrease the generating heat. This is a guide rail allow for easy decortication. This is a guide rail. It has a sharp edge and a guiding path. Its a sharp tip is designed to perforate the cortical bone, and while the middle part serves as a guide part for final rail. Osteotomy was created by guide rail is designed to fit the tip of the final rail, ensuring precision directions. We provide the stoppers for one rail to easily control the depths, osteotomy depths. Just like this, and you can make it osteotomy hole. The one rail minimizes the surgical time, reducing complications and increasing the satisfaction for both patient and the dentist. Only 3 steps, placing implant. Step 1, using the guided drills, initial positioning with the guided drill. And osteotomy was using the final drill for the fixture. And the step 3, implant placement. That's it, that's all. Just needed the 3 steps. And the one drill also allow for autogenous bone collecting, with gathering the autogenous bone. As you can see that these tables of 3.8 diameter drills can collect 0.0 cc's autogenous bone. And the 4.0 can get collected 0.07 cc's. 4.5 diameter final drills can get 0.1 cc's autogenous bone. 5.0 diameter drills can get 0.13 cc's autogenous bone. Like this, we can collect the autogenous bone. To easily control the autogenous bone, we provide the opener and as well as a holding drill and a pushing drill tool. The one drill consists of 2 parts that can be separated, just like this. This is how the autogenous bone can be collected using one drill. After osteotomy, bone remain inside the drill. Here, one drill is placed into the holding drill tool. This is a holding drill tool. This is placed into the holding drill tool. To remove the bone from the drill, opener is inserted into slot. You can unscrew this part. After that, holding drill tool is removed. The bone can be pushed down. This pin part of the holding drill tool. Then you can get the autogenous bone here. This is the one drill sequence protocol. If you want to place the 1.5 by 10 millimeter fixture, place it in normal bone. This is a normal bone protocol. After elevating prep, firstly you can go with a guide rail. And stoppers for 10 millimeter length fixture is attached to the one drill. One drill is for 4.5 millimeter diameter should be used. One drill is then used at the osteotomy site following the guide rail. This is a guiding part, and follow the guide final drill so you can make it a osteotomy 10 millimeter legs. This is a normal bone protocol. Place the 5.5 by 10 millimeter fixtures placed. Attach the cover screw and followed by the suture. Plywood suture, that's all. This is a hard bone protocol. If you want a 4.5 by 10 millimeter fixture in hard bone, using the guide drill is the same as well in normal bone. The same stoppers are used for 10 millimeter fixtures is also. And attach it to the one drill for 4.5 diameter. Osteotomy should be done in the same manner, like this. However, in the hard bone, the bone core will remain on their side, just like this, rather than in the drill. Tweezers should be used to remove the remaining bone core. In the hard bone cases, most of the cases, the hard bone core remain in the osteotomy site. Normally in the lower anterior, that case is that if you use it in one drill, bone core is remaining here. So you can using this tweezer. We provide a tweezer and very sharp edge tip, like this. You can pick it out. There's a bone cover in hard bone cases. After the profile drills should be used in the hard bone cases protocol, we need you can get a lot of stability. It is hard to place the implant, so you need to use this profile drill. So we also provide a profile drill every each size, diameter size. There is a this is a soft bone protocols and two kind of a protocol for soft bone cases. Using the guide drill is the same. Guide drill is the same. First protocol, if you place the 4.5 zero diameter by 10 millimeter pictures, is to be placed. You pick the 4.0 diameter drills is selected, not the 4.05 drills. One size is smaller than a picture diameter. This is smaller, and stopper is for 10 millimeter length. You make a osteotomy, just on the side flap in soft bone. Second one is the second one. If you place the same, the 4.5 by 10 millimeter pictures, using guide rail is the same. And one size is smaller than the picture diameter is selected. Just a 4.0 millimeter diameter drills is selected. And when you select the stopper, is using an 11.5 millimeter stopper, not a 10 millimeter. It's a longer length. You use a longer length. Osteotomy is longer. However, stopper should be the set for 11.5 millimeter, not for 10 millimeter. So you make it a longer osteotomy for soft bone. Then the osteotomy should be longer than a picture length. After that, you can make some cases that you need some proprietary 4.5 proprietary. That depends on. But this is the second soft bone protocol. This part. I represent the poor mouth implant cases using OneDay protocol. This is a full edentulous case involving both maxilla and mandible. And actually, I placed 8 S fixtures on OneDay Biotech. This is a pre-op. I placed 8 S pictures in upper mandible, maxillary. 4.5 millimeter pictures length, 11 length. This is a wall lace for releasing incisions. I picked the guide rail. 8 mark for guide rail. I placed the 8 as pictures upper. I picked the 4.0 diameter one drill on the size of the one drill. I don't use the stoppers in the upper cases because there is no dangerous structures in the upper side. I don't use the stoppers in the upper side. Unscrew this one drill that I can get that the autogenous bond is here. You can see the autogenous bond. This one is the 4.5 diameter one drills. I'm going to place the 5-0 diameter upper molar, 2 pictures, sinus graft. So I use a separate. The vertical sinus graft. Reading also densification bar. So you know that the denser bars, there's a mimic the denser bars and the Korean ones that not actual the denser bars, but I'm using that. I placed the 4.5 S picture. Six 4.5 11 by 11.5 millimeter picture. This is a S picture. Usually I place it on under the 2 or 3 millimeter under the crescent bone, submerged. Connect the healing abutment and posterior 2 teeth. Anterior 6 pictures, I connect the transfer abutment to make it immediate loading. For the aesthetic enhancement, abundant GBR was done in actually anterior region. This is a bone cover, autogenous bone. I use a cover the collagen membrane. Kissure was done to fix the membrane. And followed by suture. This is a 6 abutment. So this is a lower. Patient had a run ill-fitting denture for a long time, which resulted in severe mandibular bone resorption. I usually vertical incisions in center. I don't want to harm the mental parameter, so I don't use the distal and the vertical incisions. This is for the position where the mental parameter is. I identify the mental parameter. This is for the mallo guide osteotomy. I place the mallo guide in center. This is a guide rail. I'm making a decodification for finer guide rail. Finer rail. This is one drill. I use the 4.0 diameter drills. I use the 4 by 11.5 diameter fixtures. This is the angulation, a 30 degree tip. I don't need an autogenous bone in all cases, so I don't care about it and bones. And this is autogenous bone here. But place the implant in lower. This is a 4.0 by 11.5 millimeter S picture, OneDay Biotech. Place the implant with a 30 degree tilt. This is posterior, 30 degree tilt. I connect MUA. This is a straight multi-unit. This is an angled, 30 degree angled multi-unit abutment. This is a 30 degrees multi-unit abutment. Make sure that all the retaining screw hold parallel. You can check the parallelism is very important. But this front one is not parallel, so out of the line, so I changed the 17 degree angle to MUA. After that, I cover the compote cap. followed by the suture. This is a vertical incision. I usually in these extremely reserved cases, I using a vertical incision in center of the mandible, not distal. So for the provisionalization, I deliver fixed temporary upper side and the lower overdenture, mandible overdenture, supported by the MUAs with a composure cap. This is a preoperative panoramic view X-ray. You can see the CT view pre-op. This is a mental parameter. There is no room, no bones to place an implant. In this case, the only viable option is all-on-forward case. This is a post-op panoramic view. I placed 8 as picture, maxilla, and 4 as pictures in the mandible. I connected multi-unit abutment lower, and the upper is a transfer abutment angle and a straight abutment. Here is a healing abutment. That's vertical sinus graft here. Vertical sinus graft here. One straight. These are MUAs and a 3 angled MUA. The mark indicated the position of the metapramen. This is a metapramen, where the metapramen is, and V line represent a 30 degree angulations, osteotomy performed with a 30 degree tilt, parallel to the line here, indicated by the Malo guide. But usually Malo uses 45 degrees angles, but the Paulo Malo uses the external connections, but usually internal connections are supported in 30 degrees maximum, but some companies support at 45 degree angle MUAs, but they're not normals, they're not usual, so I tilted 30 degree. This is a post-operative panoramic view after delivery of the final prosthetics. For zirconia prosthetics and substructures are sometimes using metal frameworks or without a framework that. This is an internal view after delivery of the final prosthetics. Gingival portions and teeth of final prosthetics appears very natural and aesthetics. The patient was extremely satisfied with the prosthetics and really loved the transformation of his smile. I will introduce my OneDay Biotech implant pictures. This is a OneDay Biotech S picture. This one is S picture. This range allows you to manage a wide variety of bone conditions. Even with a thorough CT analysis, you may still encounter the unexpected bone quality or anatomy during an implant placement. In such situations, as pictures provide a versatile solution to address most clinical challenges. This is a OneDay Biotech as mini picture. As many pictures ranging from 3.0 from 3.3 available in 2 options. Lengths are ranging from 8.5 to 13 available in a 4 option. Although not listed in the catalog, the system is approved for lengths of up to 15 millimeter. While 15 millimeter implants are not kept in stock, production is available upon request. Technically, this provides 5 length options. We can provide 5 length options. This is an empty act picture. Empty act picture diameter ranging from 3.8 millimeter to 5.0 millimeter, available in the 4 options. Picture length ranging from 7 to 15, available in the 6 option. Now implant features and SLA surface. The image shown here is as SME image of our fixture. You can see the roughness. Surface is highly roughened. And the recommended RA value ranging from 1.6 to 2.4, and we maintain an RA value approximately 2.0. This is the RA value. RA value is approximately, our implant surface is maintained 1.8 to 2.0. If it is too small, bone integration is poor. If it's too rough, there is no increase. There is an increased risk of infection. So the reason why we control the RA values of 1.8 to 2.0. This is the acid etching procedure. I will show you the design characteristics of acid fixture. These are the design acid fixture. So it has a bevel shoulder that helps reduce the coronal stress and promote bone growth over the shoulder. Taper design here. Taper design here provide the initial fixation and easy depth controls and ideal torque controls. This is a taper part. Single straight core design that helps minimize the bone trauma and during osteotomy and insertion. And round apex helps protect the sinus pro and protect the mental foramen. As picture features different from geometry in the coronal and apical region. The thread pitch is the same, just on 0.08. The pitch is the same. Constant 0.8 millimeters throughout the whole picture. But however, the thread base width is different. This is a 1.45. This is a 0.35. Different from the coronal to apical portions. As a result, thread pitch and flank angles remain angle is the same here and here, but we can feel the same feelings in one flank angle. But while the thread geometry varies regionally, but geometry is different, as the depth is a different 0.25, here is a 0.4. This created hybrid thread design and combined different mechanical functions within a single imprint. With the identical pitch and flank angle varying thread base widths and depths enable apical cutting efficiency and the coronal load control. Achieving a predictable insertion reduces bone trauma here and optimize the primary stability here. As pictured, features a double thread that offering the following advantage. Fast insertion, enhance primary stability and stress distributions, and reduce the insertion torque, ideal for low density bone. So we can apply the double thread as picture. OneDay Biotech implants are based on an internal submerged design, which provide well-recognized advantages, including platform switching. You know the platform switching. However, older internal submerged implant cannot completely avoid one fracture, just like this. And every company is trying to overcome these issues. To enhance material stiffness, we use the titanium supplier by Carpenter, well-validated and global recognized company manufacturer. For implant fixtures, we use a cold work grade for commercially pure titanium for fixture. Cold work grade for pure titanium and abutment for titanium alloy, ELI. Cold work is annual titanium offers advantage over standard grade 4 in terms of strength. It exhibits a yield strength approximately over 600 megapascal and tensile strength exceeding 650 megapascal. Elongation is reduced by 3 to 5%, and compared with grade 4 pure titanium. While hardness increased approximately 30% increase. OneDay Biotech implant features 11 Morse taper degree. 11 degree Morse taper connection, similar to Astra Tech's fixtures Astra system. However, the depth of the end of the hex depth is 2.5 millimeter. The shorter hex depths increase the thickness of the implant wall here, which reduces the risk of the fracture. The hex size itself is identical to Astra and follows the universal 2.5 hex standard. In Astra types interconnection systems, there are two types of abutment connections. It's just one point contact. This is the hex depth is usually very deep, but the double contact systems usually hex depth is shorter than this one contact. Dual contact connections offers advantage over the single contact design. Single contact are more frequently associated with the screw loosening as well as an abutment and a fixture fracture. We can apply 11 degrees Morse taper connections. We can use dual contact which provide more favorable post-distribution and reduce the stress in implant and neck region. This is the S mini picture. Our OneDay Biotech mini picture features 1.7 hex connection, which allow a 3.0 diameter picture and 3.3 diameter picture. It is an ultra small diameter implant picture. 1.7 hex allows for the thicker fixture wall, and compared to the 2.1 millimeter hex. So I explained the MTX. This is an MTX fixture. It features moderately aggressive design. There are the design characteristics of an MTX fixture. It features a micro ring at the leg, a smoother and more scared, less aggressive in the corner portion, and deeper and more aggressive thread in the middle and apical portion. It's designed to maximize primary stability, reduce the corner compression, and preserve the crestal bone here because of the micro ring here. The MTX picture is designed with a tapered core and the deep thread geometry to enhance the primary stability. This is how the MTX fixture looks. This drawing is intended to simplify fixture design. MTX fixture is designed to improve engagement with the socket walls in the immediate placement cases, reducing the jumping distance, and enhancing initial fixation. It can be achieved a stable anchorage with even with the under prep osteotomies without causing excessive bone trauma. A smaller thread pitch increases the bone to implant contact, improve load distribution, and reduce microstrain at the bone to implant interface. Support immediate or early loading. The hybrid cutting and condensing thread design allow effective bone cutting while simultaneously condensing cancellous bone here, rather than excessive removing it. This created a bone environment similar to osteoidentification. This is thread and making osteoidentification, resulting in high insertion torque with predictable control. As a result, implant stability is enhanced, leading to improved ISTQ value, and particularly in the soft bone condition. The micro-ring at the neck here allows for optimal stress distribution at the crestal bone, resulting in minimizing and marginal bone loss and enhancing a soft bone stability, particularly in immediate placement cases. OneDay Biotech offers a two implant system, MTX and S. This is MTX, this is a S fixture with a distinct clinical philosophy. MTX system is a stability driven and feature deep and aggressive thread that generated high insertion torque. It particularly suited for immediate placement cases and immediate loading and a poor bone. In contrast, the S fixture is a design with a bone-friendly and universal approach, moderate thread design, and provide a controlled insertion torque and ideal for heel side and standard clinical cases. OneDay Biotech MTX is similar to Straumann's BLX, shares a common design concept that is well suited for immediate placement and immediate loading. There, the tapered geometry provides a high primary stability, and particularly in soft bone. Both systems are designed to maximize the primary stability, with preserving bone in challenging clinical conditions. OneDay Biotech MT Active and Straumann BLX are both aggressive implant systems designed for immediate placement and soft bone conditions. While both systems share the taper body and taper body shape, taper body shape and a cervical micro thread design. Cervical thread, micro thread. This is a cervical thread with provide a micro ring, and combined with a self-cutting apical design. Self-cutting apical design that provide enhanced guidance during placement. This approach promotes bone condensation and control, contributing to high primary stability. In contrast, BLX utilizes a deep cutting edge thread, cutting thread with a self-cutting, BLX self-cutting and apical design, focusing on more bone cutting to achieve initial stability. Both systems are optimized upon immediate placement in a soft bone. However, MTX emphasizes bone condensation. This part for the bone condensation and guided insertion. While as the BLX prioritize cutting efficiency, thread design is all the same entire fixture. MTX implanter offers several key advantages over BLX, particularly in challenging clinical conditions requiring immediate implant placements. It's a taper core. MTX using a taper core and scared thread. Here is the scared thread. Design promote bone condensation rather than excessive bone removing, enabling predictable primary stability with reduced surgical trauma at the crestal level. The beveled neck design, this is the beveled neck design, helps to preserve crestal bone by optimizing stress distribution in the cervical region, In addition, MTX features a high compatibility with the astrotype internal connections through the 11 degree connections, allow the reliable prosthetic integration. Most tapers, the tapered core design also reduce. This is a core tapered core reliable. Tapered cores design also reduce the jumping distance in extraction socket, just similar to the extraction socket. So you don't need any grafting, additional grafting, making MTX tape special suitable for immediate placement and reducing need for additional bone grafting procedure. Let me introduce our unique products, especially designed for easy and fast implant placement. This is called a multi-scan mounted implant. This is called an MSM implant. Perform a multiple function within a single component. I'll show you the introduction video. Extract the teeth and place the implant. Then immediately scan it. You can handicap after 2 or 3 months later. This is a back office in dental works, making a prosthesis. The patient come and deliver the crown. That's it. This is an MSM implant. Multi-scan mounted implant provide a multiple function in a single component, serving as a mounter and scan body, healing abutment. This is an abutment, final abutment. This paper shows how abutment retrieve affect many marginal bone loss during the healing period. The process of removing and reconnecting abutment causes additional marginal bone loss. In conventional implant surgery, clinicians usually connect the healing abutment and connect healing abutment and removing it, and after later reconnect another abutment. Sometimes you take a impression, you are coping and removing it after the cover screw with reconnect and healing abutment and reconnect. It causes a lot of making a bone loss. This repeated abutment and manipulation can disturb the peri-implant tissues and lead to marginal bone loss. The authors of this study concluded that the one abutment, one-time protocol is biologically favorable approach because it avoids repeated disruption of soft tissue seal. MSM implants are suitable, especially suitable for this concept. So one abutment at one time, no need to retrieve. This will allow the clinician to place the implant, complete the prosthetic work without an abutment retrieval. This is a concept of the MSM implant. MSM implant specification will allow adjustment according to the occlusal clearance. High profile, mid profile, low profile. This indicated this laser marking in every 2 millimeter. It can be shortened in channel side. You can cut here. You can cut here. Clinician may choose a precise 2 millimeter or 4 millimeter. If you're not skillful in cutting this part, you can change this one. But originally proposed is without a retrieve is not for the original proposal. Gingival height of a MSM implant is 3 millimeter. We oppose only single 3 millimeter gingival height to simplify the clinical procedure and eliminate unnecessary decision making during the treatment planning. According to these articles, the hormones, there's one piece needed at 2.93 millimeter biologic width. All the sums is here, then the 2 pieces needed 3.14 millimeter biologic width, approximately generally known to be 3 millimeter. So gingival height of the MSM implant is designed accordingly. So biologic width. This is a clinical case video demonstrating MSM implant. Video was recorded on iPhone, so I appreciate your understanding the video quality. This is a pre-op. I extracted tooth molar. This is using a bone plating, but the immediate cases the socket septum is very sharp, the plating. So with that kind of denture burr, we provided that kind of burr. And guide rail, it is a little bit challenging to making guide rails in a extraction socket, especially in a molar cases. And the one rail, I checked it, depths. Unscrew the one rail and collect autogenous bone. Collect autogenous bone. I placed MSM implant. This is an MSM implant in the previous version. I placed the skin mounted implant, MSM, and multi-skin mounted implant. You can place. Then this is removing a friction, just a torque wrench with the torque wrench, giving a more torque here. Now after that, removing this is a friction grip. Removing a friction grip and connect the healing cap. In this case, is immediate placement, but the healed reach, you don't need to connect the healing cap before the scanning. But for the GBR, I checked the occlusal clearance, but is it enough? So GBR. For the GBR, you need to connect the healing cap before the scanning, scanning the MSM implant. GBR followed by suture, and then removing the healing cap and scan it. You scan and scan. This is the post-op on the day of the surgery. This is a healing cap, and 3 months later, then remove the healing cap and the prefabricated zirconia crowns are delivered. No need to retrieve. Just only removing a healing cap. There's a healing cap levels and interfaces and abutment level. In the connections, the pictures are no need. We prevent marginal bone loss. Deliver the crown here. So it's just a very simple way to deliver the crown, deliver the implant placement. I will show you another case involving an implant bridge. MSM implant designed for use with the implant bridge. Many companies have this kind of size, the multifunctional mounter and a scan body, but that case is only for support. This is a single crown. But our MSM implant support and allow the bridge cases. It is a pre-op panoramic view. So immediately place the 2 MSM implant upper and 2 immediate implants lower, along with the GBR. This is a post-operative panoramic view. This is the upper, and this is the lower. This is a healing cap. 4 multi-scan mounted implant was placed in the maxilla and the mandible. Healing cap was connected. This is a pre-operative intraoral view in the mandible. I appreciate that your understanding. This is my newly trained staff taking a picture, so a little bit focused up, so not good photographic quality. Post-extractions intraoral view showing an intact septum here, intact septum here. This is a guide rail. This is a guide rail. This is you can see the perforator created by the guide rail. The osteotomy highlighted in the circle. That the guiding point for the final drill. This is a guide for the final drill. This is a guide for the final drill. In general, performing osteotomy in extraction socket can be challenging. When using a guide drill in extraction socket, it is important to hold the handpiece firmly to prevent slipping and to apply control and steady pressure. It's hard to making this guide preparation, cortication. This is a final drill. This is a final draft. You can see the bone cover here. You can see your bone cover remaining within the extraction socket. It's not observed in the posterior regions. When using a one drill techniques in dense bone cover may occasionally remain in the site. In such a case, a bone can be gently removed using tweezers, as I told you. This is an intraoral view showing the MSM implant after the placement. Pass is a little bit, this is a buccally, but you can make a bridge, just like a multi-unit abutment. Place the implant, removing this friction grade and connect the healing cap and GBR. And the GBR was done, followed by suture, and removing the healing cap, you can scan it. Yeah, after healing period, you can deliver this bridge, screw retained zirconia bridge. This is a screw type prosthesis. Filling with the screw hole with resin. You can make it as bridge, implant bridge. Same as in the upper. This is a pre-op intraoral image. Extract the teeth and place the MSM implant. Yeah, extraction immediate implant placement. Removing a friction grade and connect the healing cap for the GBL. GBL was performed using porcine bones. I usually use the porcine bones and graft materials combined with the fibrin. And PRF was placed followed by suture. This is an intraoral view 3 months later after the surgery. Healing cap. This healed is not completely healed, but in the MSM picture was a scan on the day of the surgery. The low profile prosthetics was then fabricated in the dental lab, the back office. MSM implant pictures amount was adjusted accordingly to achieve the low profile configuration. You can see the low profile abutment here. Cutting surface appears slightly rough because it was adjusted intraorally using a 330 bar. So it cut here intraorally without the retrieve. If you make it this one, so you can change this one, the low profile prefabricated one, you can change, but you can cut here in intraorally. After the delivered crown, screw retained crowns here. Full zirconia as a screw retained prosthetic in place, and the screw access hole was filled with a resin. This is a post-operative panoramic view. 4 multi-scan mounters implant was placed in the maxilla and lower mandible. Screw retained the full zirconia prosthesis was delivered. This is a flat end, the screwed prosthesis, just like a multi-unit abutment you can see. Per zirconia. You can make it a per zirconia and a bridge crown, bridge implant bridge. As explained earlier, MSM implant is multifunctional. It is also function as a mounter, allowing an MSM implant to be picked up and placed using a picture driver. Just like this. It can also scan. Removing a friction grade, you can scan it. MSM implant functions as a scan body, allowing a scanning to be performed immediately after the placement without a removal. This is a bar type scanner, bar type scan body. Okay. In edentulous case or multiple long span in scanning situations, bar type scan body can be attached to the MSM implant. Like this. This is how it looks. In edentulous cases, bar type scan body is attached to prevent the distortion of the scanning data. The healing cap is attached directly to the MSM implant with no need to remove the upper portion of MSM implant. You don't need to remove it. And MSM implant itself functions as a final abutment. This is a final abutment, eliminating the need for retrieval. As shown earlier, MSM implant function as a various abutment profile depending on occlusal clearance, including high profile, mid profile, low profile configurations. High profile configuration allows cement retain, screw retain, and screw and cement retain prosthetics. Screw type and crown also. This is a cement type, high profile configuration, and 6 millimeter length. And SystemSEP screw and cement retain the prosthesis type. You can make it a 2.5 screw hole. And this is a screw type. Without cement, you can make it this one. But the demerit is a hole is bigger than this one. As the 6 millimeter MSM abutment height ensure adequate retention for cement retain restoration. This is cement retain, the cement type crown. You can also make it a screw retain and cement retained prosthetics. After seating the crown with the cement, 2.5 millimeter screw drive can be accessed. Allowing the crown and the abutment can be removed together as a single unit of necessary. This is a screw type crown. You can make a screw type a single crown. MSM implant abutment has an internal screw tab. Sorry. Screw tab inside. Screw tab inside. You can make a screw tab without a cement. Middle profile configuration allows cement retain, screw and cement retain, and the screw retain restoration is the same as a high profile configuration. This is the middle profile configuration. This is a 4 millimeter. You can cut intraorally, or you can use a prefabricated 4 millimeter abutment. This is a MSM abutment can be adjusted intraorally and replaced with a prefabricated abutment. This is a cement type. This is a SystemSEP type. You can make it a screw type also, single crown. This is abutment. This is cement type. This is SystemSEP. High profile. This is a 2.5 screw access hole. You can remove it. You can move together. And also you can make a screw type prosthetics, the single crown. In the low profile, you can only make it a screw type crown and the bridge. You can make a bridge. In low profile, conventional mounted types abutments are typically limited to single crown restoration. However, MSM implant is uniquely designed to support screw retain bridge restoration. In addition, the MSM implant incorporates MUA functionality and can be used in the same manner as a multi-unit abutment. Just like this. This is a MSM implant. The low profile configuration is a 2 millimeter. It has a hexa, just like a multi-unit. Our hexa is a multi-unit abutment. You can make a single screw type, low profile configuration crown. And also you make it this kind of bridge cases. You can make it as a bridge, implant bridge. This is a screw type retained single crown. This is, you can retain the screw. This is a screw retained single crown, and this is a bridge. You can make a bridge and screw tightening. This is our unique product which embodies my treatment philosophy and easy and fast, precise. So this is a one drill. This is an MSM implant. And this is a picture is a design that's just like a BRX design, it's very aggressive in immediate loading and immediate placement. So simplicity is our highest value, and we'll help you perform surgery easily and quickly. Thank you. Yeah, any question? No question? Anything about that? It's yeah.
In case of immediate that you show in present, I want to know how to check the stability of the implant.
Firstly, I checked in a torque wrench and a torque, and another thing is ISQ value. ISQ value is over but usually I torque in the over 60 newtons. Over the 60 newtons, I will a little bit because of it. All the cases are immediate loading in the premolar area, not the posteriors, but yeah. Even though the immediate placement or even immediate placement and GBR and with the immediate loading, that the cases are over torque, a little bit over torque. But the success rate a little bit lesser than 1 point or 2 points less than conventional submerging cases. In my experience, but it's better than for the patients, the better. So I using an over torque, and sometimes I check the ISQ value is but 70 or yeah. Is there any questions? Especially I'm interested in a T-scan occlusion. Yeah.
In a low profile with like a zirconia,
Yeah.
there must be sometimes have a break with the joint
Yeah.
compared with the metal.
You mean that the harness and that's I using it this zirconias, but the technology is advanced. But 15 years ago, that time I started with the zirconia with the bad man. That there is no CAD/CAM system. That time the zirconia circles that's price. That time the zirconia is not weak, not strong. So that sometimes fractured. But these days all the zirconia is strong enough. So there is no fractures about because of the color of the margin. So no need any link, some kind of metal link. I don't use the metal link. It's just directly contact to the abutment. MUA, even though all on X cases, some cases using a metal framework, but some cases are full zirconia. All on X cases are full mask cases, but it doesn't. Yeah, it doesn't. I don't care about that issues, but occlusion and the force distribution is a more important thing. Any other question?
In the case of space is too low,
Yeah.
have the scan mount implants
Yeah.
the same day of surgery or not?
Oh, say it again.
Same day of surgery. I mean, in the aspect is too short.
Yeah.
How you cut the scan mount implant?
Yeah. You mean the height, the length of the height?
Yes.
It required a little specific length of the. Okay, check the specification of the screw. It required the 2 millimeter and the head of the screw. Yeah, maybe the 1.5, but the 2 millimeter. I required a 4 millimeter, at least a 4 millimeter occlusal clearance.
And how to cut?
How to cut? You mean? So I cut the 303 diamond, 300 carbide bar. We can start with some kind of guiding jig, connecting the guiding jig and cut it out.
With the diamond bar, like that?
Yeah, carbide bar.
Is
Carbide
that
bar.
hot or not?
Yeah.
Too hot.
Yeah, it's just high speed cut.
In the same day of surgery.
Yeah, no, just a high speed.
Yes.
Yeah.
But don't in the same day of surgery.
Yeah, the same day, on the same day. No, the cutting is some cases because of the occlusion appearance clearance. At that time, you need a cut, but you need enough, occlusion clearance. You make it in deliver the crown. That time that you can cut it out. If you make it a low profile prosthesis in the prefabricated, that time that you cut it out in healing times. But you don't. But in surgery time, that you don't have any clearance. In that case, is after surgery you scan it. After that, cut it out. But enough. You have enough occlusion or clearance. In that case, is I don't cut it out in the surgery days, but the delivery day.
Okay.
Is that okay?
Doctor,
Thank you.
I have a question from a doctor from the floor. He was asking about the one drill kit.
Yeah.
Are there different drills for different bone densities?
Yeah.
This is the first question. And
Yeah.
the second question is, since you only use one initial drill,
Yeah.
when you put in the final drill, will
Yeah.
this cause the position of the final drill to change?
Yeah, that times I didn't see that, but using a high-speed burr. Yeah, high-speed surgical bars and guiding point and changing of directions. But it is hard to moving in ordinary surgical piezo. Implant engine is it is hard to control that. But I using it high speed. High-speed surgical fissure bars and making.
But for the one drill kit, there's only one type of drill for all the bone densities, correct?
Yeah.
Okay.
But I can use a choose that selecting the diameter with the same. Yeah.